All right, so sometimes you can draw multiple Lewis structures for one formula, and formal charge is something that's going to help us decide which one of these Lewis structures is correct. And so formal charge is simply the charge if all electrons were shared evenly. So if every single bond was broken up with one electron going on each atom. And so formal charge is equal to the number of valence electrons on a neutral atom, so or on a lone atom, minus the number of non-bonding electrons. So each electron pair is two non-bonding electrons, minus the number of bonds. Right, so that's what formal charge is. So let's check it out on our molecule of HF. So here's the Lewis structure for HF, which I'm sure you can draw at this point. If we think about hydrogen, hydrogen is group 1, so it only had one valence electron by itself on its lone atom. We have 0 lone pair electrons here, and then it's making one bond for a formal charge of 0. Let's take a look at this fluorine's formal charge. So fluorine normally has 7 valence electrons. It has 6 lone or non-bonding electrons, and then it has one bond, so an overall formal charge of 0. So both of them have a formal charge of 0, and low formal charge is good. So just some things. Here, it's that the sum of the formal charges must be equal to the overall charge. So let's take our hydroxide, for example, that we did last time. Let's go ahead and draw out the structure. And so last time we put a bracket and negative charge. This time we're going to localize the charge, and it's going to be the formal charge. So let's take a look at the formal charge on this oxygen. Oxygen normally has 6 valence electrons when it's by itself. Here we also have 6 non-bonding electrons, and then we have one bond. And so 6 minus 1 is -1. So this oxygen has a formal charge of -1. And so what we do is we put a little negative next to it. Let's take a look at hydrogen. Hydrogen normally has 1 valence electron. It has 0 non-bonding electrons here, and it has 1 bond. So 1 minus 0 is 0. So the kind of correct Lewis structure for hydroxide is this one right here. So one of the rules with Lewis structures is that you want to minimize formal charge as much as possible. So for example, we were drawing CO2, and at one point we came to this structure before we had completed it. And I told you I was going to pull 1 electron from each oxygen to put in these bonds. That way carbon has an octet. And I told you, well, one of the other ones we could have done, or one of the other ways we could have done it is pulled both electrons from, or both electron pairs from one of the oxygens. So let's see what would happen if we did that. Cool. So there, those would be our 2 structures. And then let's calculate the formal charges on everything. So oxygen normally has 6 valence electrons. So this one, oxygen 6, has 4 non-bonding and 2 bonding. So 6 minus 4 minus 2 is 0. Carbon normally has 4 valence electrons. Here it's got 4 bonds, 0. And then again, oxygen has 6 valence electrons. Here it's got 4 non-bonding, 2 bonds, for a total formal charge of 0. So you can see we have no charges on this structure. Let's take a look at the structure on the right here. So oxygen normally has 6 valence electrons. Let's look at this one first. Here it's got 2 non-bonding electrons. So 6 minus 2 is 3, or 4, my bad, 4. And then it's got 3 bonds here. So 4 minus 3 is +1. So that one has a charge of +1. Carbon normally 4 valence electrons. Here it's got 4 bonds, so 0. And then this oxygen on the right here, 6 valence electrons minus 6 non-bonding minus 1 bond will be a charge of -1. And so we need to put a little plus here and then a minus here. And so you can see one of them has less formal charge, and less formal charge is better. And so this structure on the right is more correct. And this one over here is pretty wrong. So in that case, we got rid of all of our formal charge. That won't always happen. If formal charge is needed, if you can't make any structure where it doesn't have formal charge, you want to put the negative charge on the most electronegative atom. And that makes sense, right? Electronegative atoms pull on electrons, so it makes sense that they could hold that negative charge. And then if you have a positive charge, you want to put it on the least electronegative atom, or the most electropositive atom, as is sometimes said. And that makes sense as well. This one holds on to the electrons the least, so it makes sense that someone would come and rip an electron away. So let's take a look at these rules in OCN minus. And let's draw the different kind of Lewis structures possible and identify which one is the most correct based on formal charge. So if you think about OCN, oxygen 6 valence electrons, carbon 4, nitrogen 5, and then the negative charge, that's 16 valence electrons total. And then remember our rule, put the least electronegative atom in the center. In this case, it's carbon. So carbon's what's going to go in the center. So we started off like so. We've used up 2 bonds, that's 4 electrons, so we've got 12 valence electrons left. First, put them on the most electronegative atom, which is in this case oxygen, until it has an octet. And then the next most electronegative atom, nitrogen, until it has an octet. And then we've used up all of our valence electrons, 0 left. Now we can move around bonds to make double and triple bonds to fill octets, right? This carbon needs 2 more bonds. And so we can pull those 2 bonds, both from oxygen, one from an oxygen, one from a nitrogen, or both from nitrogen. Let's see what happens when we do each of these. Cool, so everything's got a filled octet, so in that terms it's happy, but let's take a look at the formal charges here. So if you calculate the formal charge of this first oxygen, you'll get +1, the carbon will be 0, and then this nitrogen will be a -2. So make sure you can do that, maybe pause the video and figure out the rest of these formal charges. In this case, this oxygen is 0, the carbon is 0, the nitrogen is -1. In this case, it's -1, 0, and 0. And so we can see one of them is obviously kind of the worst. This one over here has very high formal charges. Let's go ahead and draw them on there. So there's a plus here, a -2 here, a negative here, or just a negative here. Cool. So that one's obviously the worst because it's got a whole bunch of formal charges. But then we have these two, right? So we can either have the formal charge on nitrogen or oxygen. So if you're thinking about electronegativity, right, that's how much it pulls on an electron. So having a negative charge would make sense on the more electronegative atom. And so oxygen is more electronegative, and so this one is the most correct. So remember, minimize formal charge. If you have to have a formal charge, negative, put it on an electronegative atom, positive, put it on a less electronegative atom, if possible.